Hello guys, we have here an example of we have here a design of a singly reinforced beam. And we have given a task to use the USD method or the ultimate strength design. So without further ado, let's start. As you can see here, this is the example. And we have given task to determine the MU or the maximum moment capacity. D is equals to 500 millimeter, 300 width, 5 to 25, FC is 27.5 megapascal, FY 395 MPa megapascal, and note use 2010 or 2015 NSP code. So the first thing to do is to draw a diagram. But still, just like my first video, I didn't put the diagram here since I draw it on a scratch. So first thing is to deeply analyze and input the given. So the width here is 300. Let's input here 300. The effective depth 500. The number of main bars here 5. Diameter of main bars 35. FC prime given 37.5. Fy 395. And the section factor are the beta since we are considering using 2010 2015 NSCP code here. We have this condition. If FC prime is less than or greater than 30 MPa in 2001, use 0.85. If FC prime is less than or greater or equal 28 MPa to 2010 to 2015 NSCP code. So our FC is 27.5, so we will use 0.85. 0.85. As you can see, when we input the given, we will automatically get the answer. First is to calculate the balance design or the CV. So here is the formula. 600 divided by 600 plus Fy times D. So in Excel, 600 divided 600 plus the Fy 395 times the effective depth. So we will get the answer of 301.5075. Next is the steel ratio or the PB. So the formula is 0.85 times FC prime over Fy times beta times 600 over 600 plus Fy. So 0.85 times 297.5 divided by 395 times the section factor or the beta, the 0.85 times 600 divided by 600 again plus the Fy or the 395, and we will get answer of 0.03032. And the next is the steel area steel rather. Ay, paras naman sila. So n times pi over 4 times t squared, number of main bars. Number of main bars times pi over 4 times diameter of the main bar, 35, squared, power 822 is power 2. So, we'll get the answer of 2454.369. Next is the steel ratio. Here, AS over BD. And AS 2454.369 divided by the width times the effective depth. And we will get an answer of 0.016362. Next is the depth of compression block, or the A. So the formula is AS times Fy divided by 0.85 times Fc prime times P. So AS times Fy 395 divided by 0.85 times the Fc prime is the 27.5 times the width, or the 300, and we will get an answer of 138.2497. Next is the location of neutral axis, or C. And the formula is A over beta. So A 138 divided by beta. So the beta is according to NSCP 2015 is 0.85. So we get an answer of 162.6467. To get the phi, to get this, we will using this, or we will plot. So ay, mali pala. Unahin mo muna natin yung Fs pala. Sorry, my bad. So, Fs. Fs. So, the formula of Fs is 600 times D minus C over C. 600 times 500 minus the C, 162.6467 divided again by C, and we will get an answer of 1244.489. Now, the phi, we will plot it. Since 800, 1000, and we have the answer of Fs of 1244.489, we will assume that our Fs is here, just like that. Since nasa tawag nito, nasa tension control siya, we will using 0.90 as phi. 0.90. The CC here is the compression control, the TZ is the transition zone, and the TC is tension control. CC is 0.65 and TZ, we have a formula there, and the TC is 0.90, and this 0.90, 0.9. Next, we will get the MN. MN, AS times FY times D minus A2. AS 2454 times FY 395 close parenthesis, times the depth, effective depth 500 minus the compression block, depth of compression block divided by 2. And since we want to get the answer of Kn, we will divide it by power, I mean divide it by 10 to the power of 6, and we will get the answer of 417.7231. The maximum capacity. So, the formula of the maximum capacity is pi times the Mn, or pi times the nominal moment capacity. So, 0.9 times 417.7231 is 375.9508. So, our maximum moment capacity, or the MU, of this problem is 375.95.9508, and that is our answer. That's all. Thank you for listening.